Hello, my dear friends. Very good morning to all of you. I am Soham Chagad. Welcome you in science class. In our previous lecture, we have seen different states of matter, that is solid, liquid, and gas. We have seen that all the objects around us are fall in one of this kind of state of matter, that is solid, liquid, or gas. In last lecture, we have seen comparison of these three states. Let's quickly recapitulate comparison between these three states. Here in figure, you can see we have first point, that is solid have definite shape. By different activity, we have seen that solid have definite shape. I hope you can remember the activities we learnt in previous lecture, that place one object on paper sheet and mark its outline. That activity suggests that solids have definite shape. Similar point in liquids, we have liquids have indefinite shape. How we can say that liquid have indefinite shape? Because as we transfer liquid from one container to another container, what will happen? The liquid takes shape of that container itself. So we can say that liquids have indefinite shape, takes the shape of container. Now we have gas. Gas is the same kind of behavior as liquid. It is also indefinite in shapes. Now we talk about volume. So the volume of solid is fixed. Volume of solid is fixed. So here we have point, volume is definite in solid. In liquid also volume is definite. In previous lecture we have seen one activity that if we take 50 ml of water in one container and now we transfer this liquid to another container, we can see that the 50 ml remains 50 ml. There is no change in volume. So we can say that liquids have definite volume. But gas have indefinite volume. Gases have indefinite volume. How? Let's understand. For example, I have any kind of gas such as helium in one small container, say 1 centimeter cube container, 1 centimeter cube. I hope you can imagine 1 centimeter cube. What is volume 1 centimeter cube? 1 centimeter cube volume is the volume of capacity of cube of side 1 centimeter. 1 centimeter by 1 centimeter by 1 centimeter. Let's say I have 1 centimeter cube volume of cube and this cube is filled with helium gas. Now if I open this cube, what will happen? The helium gas will release. and it will spread all over the room or whatever. So now the volume of that helium is not 1 centimeter cube, but now volume of that helium is volume of room, because it's spread all over the room. So we can say that gases have nor indefinite shape and volume. Both are change. Now density. I hope you remember the word density. We discussed in previous lecture mass density, that is mass per unit volume, that is mass upon volume is density. Solids have highest density. Liquids have medium density. That means density of liquid is smaller than solid, but it is greater than gases. And obviously gases have lowest density. Now we talk about fluidity of state of matter. What is fluidity? We discussed that if the matter can flow, we can say that it has fluidity. For example, your school bag is solid, and have you ever seen that your school bag flows? No, it will not happen, because fluidity is not characteristic of solids. So here we write that solids cannot flow. But if we take one glass of water and by chance if this water came out, what will happen? It will spread on the floor. It will flow. So we can say that liquids can flow. Similarly, in previous example of helium, we say that the gas spreads all over the room. So we can say that gases can flow. So we have word fluid. We have word fluid. Both liquids and gases are fluid. And what is fluid? Fluid is a substance which can flow. That is fluid. And now we know that liquids and gases both can flow. Now we have fifth point with us, maximum force of attraction between particles. We have seen in characteristic or properties of matter that matter particles have force of attraction between them. So in solid they have highest attraction force between particles. That's why you can understand why solid is solid, because there is a more attraction. So they are at definite point. So it has definite shape. So solids have maximum force of attraction between particles, whereas force of attraction is less in liquid compared to solid. Liquids fall in between two, that is solids and gases. liquid have less attraction between the particles compared to solid. And if we talk this point about gases, gases have least force or say negligible force of attraction between particles. Gases have negligible force of attraction between particles. By this statement, you can understand why gases can flow very easily compared to liquid also, because there is negligible force of attraction between particles. So gases can flow easily, expand easily, compressed easily due to less attraction force, or we can say negligible attraction force between particles. Here we have another point in solid. Particles are tightly packed. In previous lecture, we have seen one figure. Let's look at that figure. Here in this figure A, you can see that the solid particles are very near to each other, and we call it as closely packed, tightly packed. So here we have point. Particles are tightly packed in solid, whereas particles are loosely packed as compared to solid in liquid. Here in figure we can say that the particles are near to each other, but in comparison to solid it is less tightly packed. So liquid particles are loosely packed as compared to solid. In gases also they are loosely packed. We can see in here the figure that gases are very loosely packed. How we can say that tightly packed and loosely packed? If in same volume we have larger amount of particles, we can say tightly packed. And in the same volume, if we have less number of particles, we can say loosely packed. So I hope you can understand what is tightly packed and what is loosely packed. Now our next point is based on compression. As we can see in previous lecture from one of the activity that contain series and piston and air, water and chalk particles. In that activity we test for compression of different states of matter, and from that activity we conclude that solid cannot be compressed, liquids also cannot be compressed, but gases can compressed easily. Liquid and solid are incompressible, while gases are easily compressible. What is compressibility? Compressibility, by compressing it, by applying force on this particular object, if we can reduce the volume of that object, we can say this object or this state is compressible. Remember here I use word decrease in volume, not change in volume, not change in shape, but change in volume. For example, if I take one object that is solid and if I compress it, and it will expand by sides and it will be lower height by compression, I cannot say I compress this object because the volume is still same. So I hope you can understand the difference between compressibility and change of shape. Particles cannot move, rather they vibrate only at the fixed position. Important point. Particles of solid cannot move, but it can vibrate at its own place. So here in figure, you can see that the particles cannot move because they are tightly packed, but they have some microscopic movement of particles around its place. So here we have point, particles cannot move, rather they vibrate only at their fixed position. In liquid, particles can slide over one another. What happened? In liquids, particles can slide over on one another. There is a layer of particles in all solid liquids and gases. Particularly in liquid, the particles move or say slide on one layer on another layer. So here we have point, particles can slide over one and another. In case of gases, particles can move freely. Particles can move freely. Here in this figure, we can see that it has large amount of kinetic energy. Now, if I release this particle by breaking this box, what will happen? This particle will spread all over, which means that particles can move freely. Now, reverse point of the point as we have just discussed. If particles are moving least, motion is least, means kinetic energy is minimum. Where? In solids. As the particle cannot move easily, so we have less kinetic energy or minimum kinetic energy. Why? Because kinetic energy is due to its motion, and if there is less motion, we can say that it has less kinetic energy. While in liquid, we can see the last point, kinetic energy of particle is more than solid. Kinetic energy of particle is more compared to solids. And in gaseous state, kinetic energy of particle is maximum among all three because it has larger space, less force of attraction, so it can have larger space. So the kinetic energy of particle is maximum in gaseous state. So I hope the properties, characteristics and comparison of this particular characteristic in between solid, liquid and gas is clear to you. Now let's move ahead in our chapter. Now we have point 1.4, that can matter change its state? What is that the point? We are talking about change in state of matter, which means we have three states: solid, liquid, and gas. It means that can we convert one state from another state? This is familiar to us. Let's see how. We all know from our observation that water can exist in three states of matter. By our observation and experience, we know that water can exist in three states of matter. Which three states? Solid, liquid, and gas. Water in form of solid, that is ice. As ice, water is in form of solid. In liquid form, water, that is our regular water, is in liquid form or liquid state. And when we increase the temperature of water, what will we get in more amount? Water vapor. So this water vapor is in gaseous state. So we can say that water can change its states. Ice is solid form of water. Water is liquid form of water, and water vapor is gaseous form of water. Now let's try to dig deep down in this topic. What happened inside the matter during change of state? What happens to the particles of matter during the change of state? How does this change of state takes place? We need to answer to all these questions. Now we have some question with us that during the change of state, what is happening inside the matter? What kind of changes are there in structure of matter? Now we will see this by one activity. We have topic 1.4.1, effect of change of temperature. Effect of change of temperature. We have one activity and the setup of experiment we can see here. We have one stand, burner, beaker. In that beaker we have ice. We have glass rod to stir the solution or to stir the water here, and we have laboratory thermometer. We have to familiar with this all equipments and tools we used in science. So here quickly we look at this steel stand or iron stand, burner, ice, beaker, glass rod, and thermometer. So we have this equipments with us. Take 150 gram of ice in a beaker and suspend a laboratory thermometer so that the bulb is in contact with ice. Here we have beaker. In that beaker we take 150 gram of ice, and that ice we put laboratory thermometer. What is bulb of thermometer? Here you can see the black colored and red colored part where this mercury is filled in that portion, and initially the place of mercury, that is called bulb. I hope you've seen the thermometer, and if you have not seen this kind of laboratory thermometer, then when you see that thermometer, please notice the bulb, mercury, markings on thermometer, etc. So here we have ice, beaker, thermometer and stand. Now start heating the beaker on a low flame. Now we have to start heating the beaker on low flame. Note the temperature when ice starts melting. We can read the temperature 0 degrees centigrade in thermometer when ice started convert into water. Remember, there is temperature 0 degrees centigrade when ice started melting. Note the temperature when all the ice has converted into water. Until all ice will not convert into water, the temperature remains same. Record your observation for this conversion of solid to liquid state. I hope you can understand the conversion from ice to water is solid to liquid. Now put the glass rod in the beaker and heat while stirring till the water start boiling. Now we have to put glass rod in the beaker and stir the water until it starts boiling. Keep a careful eye on the thermometer reading till most of the water has vaporized. We have to observe reading in thermometer once boiling is start, and we have to watch on the temperature till most of the part of that water vaporize. I hope you can understand the word vaporized. Vaporized means to convert from liquid to gas, particularly for water. Record your observation for the conversion of water in liquid state to gaseous state. And here also we will note the temperature when it starts boiling and get converted into liquid state to gaseous state. Here in this experiment we can notice the temperature while it starts boiling and convert from liquid state to gaseous state, that is 100 degree centigrade. That is 100 degree centigrade. So here we have one activity. In that we seen that there is water initially in solid state, that is ice. We give heat to that water or say ice. By heating it, we convert into liquid form, that is water. By further heating it, we will convert this water into gaseous state, that is water vapor. So I hope you can get the point we have discussed today, and practice the points and must write down. Practice by writing only, because if you will not write this point, you will not understand and catch it easily. So writing is most important in science subject and mathematics also. Thank you.